What are green roofs and vegetated walls? Why are they so important for sustainable and resilient cities? Green roofs and vegetated walls are technological systems used as constructive solutions for the total or partial coverage of a generic building structure, roof and/or walls that guarantee the living conditions over time of a programmed vegetation layer. They meet the definition of nature-based solutions given by the European Commission, solutions that are inspired and supported by nature, which are cost-effective, simultaneously provide environmental, social and economic benefits, and help build resilience. Such solutions bring more and more diverse nature and natural features and processes into cities, landscapes and seascapes through locally adapted, resource-efficient and systemic interventions. Green roofs and vegetated walls contribute to the achievement of some challenging Sustainable Development Goals in the Agenda 2030 of United Nations, as Goal 11, Sustainable Cities and Community, Goal 13, Climate Action, and Goal 15, Life on Land. Main benefits of green roofs and vegetated walls on the surrounding environment are saltwater control, runoff quality improvement, biodiversity enhancement, roof life increase, roof maintenance cost reduction, heat island mitigation, building insulation, noise and electromagnetic pollution reduction, air pollutants filtration capture, human well-being improvement and aesthetic value. Moreover, being installed on building covers, they do not require additional surfaces, often difficult to find in highly urbanized areas. Focusing on stormwater control, even if vegetated walls performance strictly depends on their configuration, their role is generally limited if compared with that of green roofs. Green roof both retain and detain stormwaters contributed to meet the hydrologic invariance target, that is, the restoration of both peak flow rates and runoff volumes to pre-urbanization conditions. Their performance in stormwater control can range from 45 to 80% depending on the climatic variable, mainly precipitation and evapotranspiration rate and the green roof structure, especially layer thickness and type as well as vegetation species. A typical green roof stratigraphy consists of vegetation, the growing medium consisting of a blend of mineral rich with organic material where water is retained and vegetation is anchored, the filter sheet that prevents soil particles from entering the drainage layer, the drainage element generally consists of plastic profiled elements that store water from plant sustainment during dry periods, evacuating excess water in roof drains. The root barrier and the waterproofing membrane that prevents water from entering the roof structure. The two main typologies of green roofs are intensive green roofs and extensive green roofs. Extensive green roofs growing medium thickness is generally lower than 15 cm. They can be used on roofs with a slope up to 30%. Typical vegetation includes moss, sedum and grass herb requiring no irrigation and minimal to no maintenance. Extensive green roofs are usually not accessible, lightweight and often suitable for retrofits. They provide limited insulation and water retention and are quite inexpensive. Intensive green roofs growing medium thickness can reach about 150 cm. They can only be installed on flat roofs or roofs with a very slight slope, lower than 5%. Vegetation can also include lawns, shrubs and small trees, needing periodic irrigation and low to high maintenance. One of the main advantages of intensive green roofs is that they are accessible as public spaces or gardens. On the other hand, they involve a great loading on a roof structure. Intensive green roofs give a good contribution to thermal performance of the building and have good surface water retention capacity, but involve high capital and maintenance costs. Green roofs contribute to the natural water balance restoration, promoting interception by vegetation, infiltration and storage into growing medium and drainage layer, and evapotranspiration by vegetation and growing medium. To increase the green roof's performance in terms of stormwater control, the so-called blue-green roofs can be used. They are innovative solutions that integrate traditional green roofs with an additional water storage layer. Moreover, even if the beneficial effects of green roofs are well recognized at the building scale, their contribution on the surrounding environment can be relevant only if used at a larger urban or catchment scale.